Welcome back to the Agentic AI podcast. We spend our time discussing the cutting edge, the algorithms, the LLMs, the sophisticated agents running our modern enterprises, everything from financial processing to, well, supply chain optimization.
Absolutely. The really smart stuff doing the heavy lifting behind the scenes.
Exactly. But what happens when the very ground these digital entities stand on just gives way?
Yeah.
We're talking about that massive reality check delivered on October 20th, 2025, the AWS US East 1 outage. And this was not just some routine hiccup, was it?
Not at all. It felt more like a brutal, involuntary stress test.
Right, a stress test on every single enterprise automation and AI pipeline that had, placed its core logic squarely in the cloud.
Uh-huh.
So our mission today is to dive deep into this blackout. We're not here just to recount the timeline, for history's sake. We really want to extract the critical, maybe painful lessons this incident holds.
Especially for architects, for executives.
Yeah.
The people building truly resilient agentic systems.
Yes. We need to understand how a single kind of localized glitch cascaded into this almost global operational paralysis.
And the paralysis was effectively global in reach.
Yeah.
I mean, the scale of this incident is staggering when you look at the numbers.
How staggering are we talking?
Well, for the better part of a business day, this was a significant global disruption. It degraded or completely interrupted approximately 20% of global internet traffic.
20% from one region's issue.
20%. And for nearly 8 hours, we saw over 6.5 million outage reports recorded.
Wow. 6.5 million. That statistic alone should be like the headline in every boardroom presentation right now.
You'd think so.
Yeah.
Our focus, I think, must be on diagnosing exactly why this specific DNS resolution failure cascaded, why it became a near catastrophe for AI workloads, not just generic websites.
Right, the agentic stuff.
Exactly. And what actionable steps executives really must take now to ensure their multi-million-dollar investments in automation actually achieve true continuity.
Okay, so let's start right there. The root cause, the trigger that, pulled the rug out from under those agents. What exactly was the technical spark that set this whole chaos alight?
Okay, so the problem was confirmed to be a really fundamental DNS resolution failure.
DNS, the internet's phone book, essentially.
Pretty much. And this was tied specifically to the DynamoDB API endpoint. Crucially residing within US East 1, that's the Northern Virginia region.
And DynamoDB, that's not just any service, right?
Well, it's absolutely bedrock for countless stateful applications. So its sudden disappearance, even intermittently, created an immediate catastrophic ripple effect worldwide.
Okay, so when you hear about a provider of this scale going down, the immediate corporate thought, maybe fear, is always a security breach, isn't it?
Always. You think sophisticated external attack, bypassed defenses.
Yeah, instantly drives panic, triggers massive incident response teams, the whole 9 yards.
But the crucial finding here, and maybe the relief, but perhaps also the subsequent embarrassment for some, is that AWS confirmed this was not security related. There were no malicious external actors. This was purely internal. An infrastructure misconfiguration that specifically fouled up their internal DNS propagation.
So, the system couldn't find its own vital parts.
Exactly. A failure of the internal plumbing, you could say. Even though the components were theoretically still running, they couldn't talk to each other properly.
So, okay, we dodged a cyber bullet, but the system still collapsed. That points to a much deeper architectural vulnerability, doesn't it? Especially around centralization.
It really does.
Let's look at the timeline for a second, because the duration is the key factor when we talk about enterprise automation. These aren't just 5-minute website blips.
No, these are existential risks for long-running AI inference data processing jobs.
Right, so when did it start?
The first signs, the elevated error rates, they hit around 12 to 20 a.m. Eastern Time, and it impacted 14 major services initially. Think EC2, S3, DynamoDB itself, IAM, Route 53, the big ones. Then, by 2 a.m. ET, they'd identified the DNS resolution issues. And that immediately started disrupting critical interdependent services. Things like Lambda, API Gateway.
The things that glue automations together.
Precisely.
And crucially, that initial disruption, that was just the beginning, right? It wasn't over quickly.
Not even close. That was merely the starting gun.
Yeah.
While AWS began applying mitigations, untangling internal DNS propagation, especially at that scale, it's complex.
The recovery was slow.
Agonizingly slow. We saw residual slowdowns persisting until around 12:30 p.m. ET. Midday. That's almost a 10-hour intermittent impact. Just think about that from the perspective of an agent managing millions in real-time inventory. Or an agent processing global compliance checks.
A 10-hour stutter. It's
And
not just a failure, it's an operational halt. It creates massive data integrity issues downstream.
absolutely massive. Which brings us, I guess, to section 2, the cascading effect.
Hmm.
What's fascinating and worrying is how the failure of those foundational, maybe even slightly boring services, the plumbing,
Yep.
completely decimated the cutting edge of enterprise AI.
Right.
DynamoDB's failure cascaded across globally reliant services
Hmm.
like IAM, which handles authorization, critical,
Hmm.
and DynamoDB Global Tables, handling state replication across regions.
Okay, and here's where we get specific about the pain for, for you listening who are building AI. When DynamoDB, a key value database, fails, what does that actually mean for an AI agent? An agent's defined by its state, right? Its
Yeah.
ability to learn and act sequentially.
That's the absolute critical link. DynamoDB is very often used as a primary persistent memory store for sophisticated agents.
Yeah, memory.
Exactly. So if an agent is running, say, a multi-step workflow, maybe processing an insurance claim that requires 3 authorization steps and 5 data lookups, the loss of DynamoDB means the agent literally loses its state.
It forgets where it was.
It forgets where it was mid-task, which leads to failed transactions, duplicated effort, or even worse, potential security vulnerabilities if a task gets abandoned mid-authorization.
Ouch. And the impact went straight up the stack to generative AI too, didn't it? AWS Bedrock was hit.
It was. Bedrock endpoints became temporarily unreachable.
And for enterprise users, that's not just an inconvenience, is it?
Far from it. It meant that Bedrock-based applications, anything from custom financial forecasting models to internal knowledge retrieval systems, saw severe degradation.
And training.
Critical retraining jobs, the ones essential for preventing model drift in high-velocity environments.
Yeah.
They were paused entirely, couldn't run.
Wow. Okay.
And this, in turn, triggered massive Lambda backlogs.
Ah, the glue again.
Right. Lambda runs those event-driven automation pipelines. If the Bedrock inference call fails or the DynamoDB lookup fails, the Lambda functions just retry and
Yep.
retry and retry,
Milking the whole system.
effectively clogging the entire system. And that's exactly where your sophisticated automation pipeline just grinds to a complete halt.
And beyond the AI training and inference, you mentioned IAM. Authentication and workflow orchestration services were crippled. That sounds existential for agentic architecture.
It really is. We saw reports of temporary IAM authorization mismatches.
That sounds like a nightmare scenario for security architects.
It's pretty much the ultimate nightmare. An IAM mismatch means the agent, your automated worker, suddenly loses or misidentifies its authorized identity mid-task.
So it can't proceed securely.
Exactly. Your compliance automation, your financial transaction agents, they cannot securely proceed, which forces a system-wide safety shutdown.
And the real-world impact was immediate. And financial. We saw Coinbase and Robinhood trading platforms temporarily halting transactions.
Precisely. If you're operating high-frequency trading agents, milliseconds matter. So when API gateway starts rate throttling, disrupting fundamental authentication and data lookups, as was reported, the transactional integrity is instantly compromised.
And e-commerce.
E-commerce platforms like Amazon itself, Shopify, Etsy, they saw their checkout API latencies exceed 3 seconds on average during the peak disruption.
3 seconds. That's an eternity in checkout.
It translates directly into abandoned shopping carts. Immediate, quantifiable revenue loss.
Okay, so this October 2025 event, when you put it alongside previous incidents like the network congestion in 2021 or the authentication overload in 2023, it feels less like a warning shot and more like, I don't know, an architectural directive.
I think that's a good way to put it, relying solely on US East 1 for mission-critical interwoven agentic systems.
Mm.
It's now a proven liability.
The operational convenience of just putting everything in one region, it simply doesn't justify the existential risk anymore, does it?
Not for these kinds of workloads. Which raises the absolutely critical question for decision makers. If you've invested millions in sophisticated automation and AI agents, how do you architect those systems to actually shrug off these kinds of foundational infrastructure failures? What does true resilience look like in practice now?
Well, industry analysts in their postmortems seemed pretty clear that companies that had multi-cloud redundancy or maybe specialized failover DNS solutions, they maintained significantly higher uptime.
They did. They essentially built systems assuming the infrastructure beneath them would fail at some point.
But let's be realistic here. Isn't full multi-cloud prohibitively expensive and complex for, say, most mid-sized enterprises? It feels like it could double your operational overhead.
That's a fair challenge, and it's why the advice needs nuance. Multi-cloud doesn't necessarily mean running your entire fleet on 2 or 3 providers simultaneously, all hot and ready.
Okay.
It means architecting specific mission-critical services like your persistent state store, maybe DynamoDB, or your authorization service, IAM, to fail over gracefully to a different provider, or at least a different region outside the affected blast radius.
So targeted redundancy, not wholesale duplication.
Exactly. The key is identifying those singular points of failure. If DynamoDB is your agent's memory, you need that memory replicated and accessible somewhere else, even if the primary region goes dark.
Okay, so let's get specific then. Beyond just a general multi-cloud strategy, what are the core actionable steps coming out of the post-mortem analysis? What should CIOs and CTOs be doing right now?
Okay, 3 main things stand out. First, as we just discussed, you must architect failover for your critical foundational APIs, DynamoDB, IAM, those bedrock endpoints, outside a single AWS region.
Outside the region, not just cross-region within AWS.
Ideally, yes, because many of the issues stem from regional DNS propagation problems. So cross-region AWS failover might still have been susceptible in some scenarios. You want a truly separate fault domain.
Okay, got it. Separate fault domain. What's number 2?
Second recommendation focuses on monitoring and visibility, which seems vital if the internal plumbing is the issue, right?
It makes sense.
So the second step is to deploy independent DNS and monitoring layers.
Independent, meaning not reliant on AWS itself.
Yes, exactly. Gartner specifically cited using solutions like Cloudflare's D1 or maybe Azure Traffic Manager as practical examples. If your entire system for detecting failure, including your notification and failover mechanism, relies entirely on the cloud provider that just failed.
You're flying completely blind.
You are flying completely blind during the most critical hours. You lose the ability to make automated, agentic decisions about mitigation because your monitoring is down too.
Right. Your watchdog needs to live outside the fence it's guarding. Makes perfect sense. And the third point. That seems paramount for those running sophisticated event-driven AI workflows. Stress testing.
Absolutely critical. You must actively stress test your IAM setups and your event-driven Lambda automations, specifically against service lag conditions, not just complete failure.
The intermittent slowdown, not just the blackout.
Precisely. That 10-hour intermittent impact was arguably more destructive, more insidious than an instantaneous complete blackout would have been.
Why is that?
Because when a service like DynamoDB is just slow, your AI agent can't necessarily just stop cleanly. It has to handle, say, a 10-second latency on a crucial lookup. It needs logic to decide. Do I wait patiently? Do I retry? Do I switch to some kind of degraded operational mode?
You're basically defining a whole new level of operational maturity here. Building agents that don't just work when everything's perfect, but that can function intelligently even in a degraded state.
That's the goal. And look, AWS acknowledged the severity. They stated they are implementing enhanced DNS partitioning and inter-region failover automation internally.
Which is good. Necessary.
It's a massive, necessary architectural shift within the provider itself. Huge undertaking for them.
But the enterprise can't just wait for AWS's internal fixes, can they? Those will take time to roll out globally to test. The vulnerability exists today.
Exactly. You can't wait.
Yeah.
If we connect this back to the bigger picture, that October 2025 outage was a definitive and frankly costly demand that enterprises shift their strategic priorities.
From convenience to resilience.
We must prioritize multi-fault domain resilience over single cloud operational convenience, especially for these agentic workflows that are so tightly coupled to foundational services like DynamoDB for memory and IAM for real-time authorization.
That tight coupling. That proved to be the single point of architectural weakness, didn't it?
It really did.
So wrapping this up, what does this all mean for you, the listener, planning your next automation project?
It means you need to move beyond simply building agents that accomplish complex tasks. That's table stakes now.
You have to build agents that survive.
You must build agents that survive infrastructure failure gracefully. The challenge right now is ensuring that while AWS works diligently to enhance its internal DNS partitioning and failover, your enterprise automation is already architected to failover before that AWS fix is fully pervasive.
So the final, maybe provocative thought we leave you with is this. Consider the impact not of a total AWS failure, but of that 10-hour intermittent slowdown we discussed. How much revenue would your most mission-critical, agent-driven workflow lose if every single DynamoDB lookup suddenly took 8 seconds instead of 8 milliseconds?
Yeah.
And maybe more importantly, how much of your current infrastructure is even built to detect that kind of latency degradation, let alone adapt to it?
That's the question.
That feels like the real test of resilience you face today. Something to think about.